Hey guys, now time for a quick review on solving equations. So in solving equations, important thing to remember is your inverse operations. Now inverse operations undo each other. So in terms of what's going to undo addition, what do you think that is? That would be subtraction. Subtraction. So in terms of undoing each other, let's say I start with 2 and then I add 5. Well, I just added 5, so I could subtract 5. And then nothing really happened. They undid each other. I still have 2. Multiplication, the inverse operation of multiplication. That would be division. Let's say I start with 2, and then I multiply by 6, and then I divide by 6. Well, 6 divided by 6 is just 1, and 2 times 1 is still just 2. Exponents. Inverse operation of exponents is to take the root. Let's say I have 2 squared. 2 squared is 4, but if I take the square root of 2 squared, the square root of 4 is then just 2. So the square root of 2 squared is still just 2. Those are inverse operations. They undo each other. Those are important because we're going to use those to solve. So the first example here is just a one-step equation. So I have t here, and I want to get t by itself. I like to think of the variable as a present that you have to unwrap. And when you're unwrapping something, you have to start from the outside and work your way in, right? So in this case, the outside, if I cover up this t, what's happening to it? I'm multiplying by 4 here. So in terms of inverse operations, to undo multiplying by 4, I have to divide. Divide by what? Divide by 4. That will undo multiplying by 4 by dividing by 4. 4 divided by 4 is 1, and that's what I want. 1t. But just like a scale that's balanced, I can't do one thing to one side and not do it to the other. Divide by 4. What is 13/4? Do not plug it into your calculator and tell me that it's 3.12 whatever it is. 13/4. That's good. As long as it's simplified, I'm good with that. So don't worry about it. 13/4. We're done. Next example. Here's t. We're in a very similar situation. What's happening to t? Well, it's being divided by 3. Well, then what's the inverse? How am I going to undo dividing by 3? The inverse of dividing is multiplying. Multiply by 3, because 3 divided by 3 is just 1, and t equals, let's multiply both sides by 3. 21, carry the 2, oops, sorry, that should be a 1, I was thinking 2, carry the 2, 3 times 1 is 3 plus 2 is 51, and t is 51. Now this is a very weird circumstance where you'll see the variable in the denominator. That's a problem. You can never fully solve when the variable is in the denominator. So what I'm going to do is get him out of there. So he's being divided by x, so I'm going to multiply by x. Well, if I do that, I have to multiply both sides by x. X divided by x is 1. We're left with 4 here. 8 times x is 8x. Now this looks very similar to all the rest of them. X is being multiplied. The inverse of that is dividing, so divide by 8. 4/8 is 1/2. 8 divided by 8 is 1. And 1x is 1/2. Remember, if I'm going too quickly for you, to pause the video or watch them again. Make sure you're taking notes and fully understanding this. This is a review, that's why I'm going kind of quickly. So here we have, here's our x, We need to unwrap from the outside. So I'm going to cover this guy up, cover up the 7x, and say, well, what's happening to this whole thing? Working from the outside, I'm subtracting 4 from it. Subtracting 4 from that. The inverse of subtracting is adding 4. I have to add to both sides. Negative 4 plus 4 is 0. 7x equals 14. What's happening here? Multiplying by 7. The inverse of that is dividing by 7 because that's just 1. And x equals 14 divided by 7 is 2. So looking at this one, what do you notice? We should notice here that we can simplify this side. It's a little complicated and we can simplify it, especially since the x is inside these parentheses and we like to get them out. So let's simplify it, something that we went over earlier in the week actually. Distributive property. 4 times x is 4x. 4 times a positive 2 is a positive 8. Equals 3x. So now I see that we have x's on both sides. That's a problem. I need this to say x equals something and only x equals something. No x's on both sides. So there's 2 ways I can go about this. Let's do it one way in red. First things first, I could say I'm going to solve for this guy here. So what I'm going to do there is then say, well, what's happening to it? Adding 8. Inverse of that, subtracting 8. Subtracting 8 from both sides, I will get 4x equals 3x minus 8. Since I'm still solving for this guy, I need to bring these x's over here. If I have 3 x's on this side, I'm going to take away 3 x's from both sides. If I have 3 x's here, I can take them away. So that is now 0. This is really being added. I could write this as negative 8 plus 3x if I wanted to. I could switch them. But I won't. I'm just going to take these away. And then I will get x equals negative 8. That's one way I could go about it. Let's do it another way. Let's say green we'll do it in. So we had 4x plus 8 equals 3x. Let's say I wanted to solve for this x. Well, I need all the x's on one side, and I need all the numbers on one side. So that's the same as this step here. So I'm going to subtract. I have 4 x's on this side. I'm going to take them away. I'm going to take them away from this side too because you need to keep the scale balanced. So I have 8 equals, this is 0. This is 3x minus 4x. 3 minus 4 is negative 1x. I don't care what negative x is, I care what x is. Since negative x is 8, I know that x is negative 8. Mathematically, I could have said that I was dividing by negative 1 on both sides. Because technically this is a negative 1 in front of here, negative 1 times x, and then I can divide both sides by negative 1. Or you could just say negative x equals 8, so x must equal negative 8. For our last example, I'm going to do one that looks a little bit scary when you first look at it.